Okay, so we're going to be looking at some statistics question. In this case, we'll be looking at discrete random variables, particularly in binomial distribution. So when we're looking at binomial distribution, we're actually looking for a situation that it is independent events, which means that the chance of, for each time you're doing an experiment, the chance of something happen is a constant probability. And also, another thing is that we're using multiple trials. So when we're trying to define the binomial distribution, we use the discrete random variable x belongs to a binomial, n represents the number of events, the number of trials, and p is the chance of success. So if we're looking at how to find a particular probability using the equation, we use px equals to r, choose r from n, that basically tells you the arrangement and order, times p to the power of r times 1 minus p to the power of n minus r. So p means it has successfully happened for r times and failed to happen n minus r times. Okay, when we talk about dependent events, that means P, A, and B. So A happened and then B can happen. So this gives us, you need to multiply the probability using the product principle. So I'm going to give you a question that pretty much integrated the concepts over here in this question. Okay, so suppose in a tennis game, each game Mike has a chance of winning Hannah by 2 out of 3. So every time you could say Mike, each game has a chance of 2 out of 3 to win Hannah. Okay, so we want to find a particular probability that Mike wins Hannah in a game of 6 by 4, and then we're going to look at the 7 by 6. So how are we supposed to find this particular answer to this question? Well, some people might be thinking, oh, this is easy. You just play 10 games and let Mike win 6 out of them. And then basically, Mike will lose 4 out of them and then find the probability. So some students might be thinking this is like x belongs to a binomial distribution, which you do the trial 10 times, and the chance of winning is 3 out of 2, and you just do x equals to 6 and substitute into the equation. Well, unfortunately, this is not right. Because what happens in a real tennis game is that if you want to play someone to 6 against 4, if you already win 6 times before you actually start game 10, let's say for example, someone has already won the first 6 games, that's already 6 against 0. So there is no chance for you to keep continuing to play the next 4 games. You can't finish up with a 6 against 4, but you finish up with something like 6 against 0 or 6 against 1 or something less than that. So we can't really do it this way. So this is not right. So how are we going to do it? Well, basically we can try to think about distinguishing this question into 2 parts. What it really means is that because we want to make sure among these 10 games, the game is not finished until you start game 10. Which means that you have to make sure there is no one winning 6 games in the first 9 games rather than 10. So in the first 9 games, you're expecting the score to be Mike against Hannah to be 5-4. And Mike wins the 10th game. So this is what happens if you want to try to find out the probability. So in this case, we have understood that, okay, so therefore, rather than using 10 games, we should be using x to represent it in a binomial distribution, just to look at the first 9 games. And the chance of winning is 2 out of 3. Okay, so basically what we can find is that px equals to 5 is therefore choose 5 from 9 and then 2 out of 3. And Mike wins 5 times, so this is the end event. And also Mike loses, well, the chance for me to lose will be 1 out of 3. Well, likely I'm winning, so I'm going to lose it 4 times. And therefore, so this is basically the chance for you to find the first 9 games, the result is 5 against 4. And then you need to go and Mike wins. So when you do a dependent event, so this is a dependent event basically. For event A, with the first 9 games, I'm winning 5 out of it, and I'm winning the last game. So therefore, the total probability for me to win 6 against 4 will be whatever this value is, and then times the chance for me to win again, which is 2 out of 3. So that's the first 9 game. And the 10th game. Okay, and then if you want to find out the exact value of this probability, you can put in your calculator, or you can try to solve it using algebra. Okay, so I'm not going to waste time on this. Okay, so then we were trying to find out, we want to develop this a bit further. So I want to find out the probability for me to win for 7 against 6. So similarly, we're going to have to distinguish this question by dividing it into a few parts, but this time we're going to do it for 3 parts. Because for 7 against 6, you can only allow these 2 people to reach 6 against 6, but before that, you need to make sure the 2 players are reaching 5 against 5 in the first 10 game. First 10 games, and then really what happens in the 11th and 12th game, well, I'm just winning one of them, win 1 game. And then what happens in the last game, which is the 13th game, you need to win. So that this will give you, well, 7 against 6. So in the first 10 games, it's 5 against 5. The 11th and 12th game is 6 against 6. And the lastly, it's just a 7 against 6 in this case. So how are we supposed to find out the probability? Well, using the same particle, we're going to say x represents the number of games I'm winning, but I'm just looking at the first 10 games. So 10, well, 2 out of 3, and then I'm going to look at for me to win 5 times. So that will give us the probability for me to play against someone for 5 against 5. So that, this will be choose 5 from 10, well, 2/3 to the power 5 times 1/3 to the power 5. Well, at the same time, that's my first 10 games. And then secondly, I'm going to go with the same binomial distribution, but I'm just looking at the 10, 11th, and 12th games. So there are only 2 games. So I'm going to play 2 games, and the chance is the same, 2 out of 3. So that I'm going to look at the probability for me just to win 1 game. Doesn't really matter I'm winning the 11th game or 12th game, so as long as I'm just winning one of them. So this will be a tied score anyway. So I'm going to choose 1 from the 2 games, so either the first or the second, and 2 out of 3 to the power of 1 times 1 out of 3 to the power of 1. So win 1 game and lose 1 game. And of course, and 13th game, you win it. So basically the total probability for 7 against 6 will be whatever you get from the first 5 games times, so n event, so it's a dependent event. So choose 1 from 2, 2 out of 3 to the power of 1, 1 out of 3 to the power of 1, and I'm winning the last game. So 2 out of 3. So this will give me first 10 games. This is the 11th and 12th, and that's the last game. Okay, and then putting this in your calculator or probably using the binomial distribution to help you, you'll be able to find out the probability for someone to win someone in the tennis game for 7 against 6. So this question actually summarizes the concept of how to apply the binomial distribution formula into an application question, but also involves a bit of thinking on the dependent events. So basically what it summarizes is that sometimes you can't, because we're limited to some particular rules in games or sports, we can't just simply assume this is just like no restriction and everything just like a basic binomial can solve. It's not going to happen. So sometimes we have to develop an analogy trying to clearly illustrate the problem and try to use dependent events to find out a particular problem.